Good morning, everyone. So my name is Upasana, and I'm going to give you all an introduction to meta-object protocol. So a little bit about myself. I'm a software developer in one of the core infrastructure teams at Booking.com. So this time you might have noticed that there is no Booking.com booth in the corridor, and there are no recruiters as well, but we are still hiring. So if you want to work with us, then talk to me or to any of my colleagues, and we'll tell you more about it. So a little bit of backstory. So in 2013, I did an internship via GNOME's outreach program for women. I worked on structured exceptions in Moose, and I want to share with you all whatever I learned during my internship. Here are some topics which I'm going to cover. So since this will be a talk for beginners, I'll cover a little bit about object-oriented programming. Then I'll talk about object-oriented programming in Perl, not using Moo or Moose, but the traditional old way. Then I'll start with meta-object protocol, a little bit of its history, its applications, then implementing a MOP in Perl. It would be very easy, not like Moose. Then I'll tell you that why whatever I did in my previous step is not a good idea. And then I'll tell you about metaclass incompatibility and a way to overcome it by using Mixins. Then meta-object protocol in Moose itself. Then drawbacks of MOP, and where to go next if you want to know more about the subject. So let's start with object-oriented programming basics. So its base is class, and a class should have a class name, and it can also have superclasses. And a class can have attributes, and an attribute have several properties, like if an attribute is a read-only attribute or a read-write. Then type of attribute, whether it's an integer, float, or string. Then default value of attribute, if that's the value your attribute should have. If it doesn't have any, if you don't pass any value for it. Then getter method, that is also known as accessor method. It is used for reading the value of attribute, and setter method, which is used for writing to the attribute. Then a class can have methods. A method can have a name and body of the method. Now let's discuss object-oriented programming in Perl. Perl doesn't really provide any special syntax for classes. Perl packages are classes. And attributes in Perl classes, again, there's no special syntax. They're stored in the object itself and as a hash of key value pairs. And an object in Perl is a hash reference, which is blessed into a class. So here's a very simple example. So I've declared my class. Its name is rectangle. Then my constructor's name is new. Then as the first argument, I'll have my class name. In this case, it would be rectangle. Then I'm treating rest of the arguments as attributes. And then I'll bless all the attributes into my class. And I can easily do this, and it works. Now let's discuss MOP. So MOP provides the vocabulary to access and manipulate the structure and behavior of objects. For example, if you want to change objects at runtime, then MOP is for you. Here are some typical functions of MOP. If you want to create new classes, if you want to delete existing classes, if you want to change structure of the class, for example, if you want to add a new method to a class, you can also change existing methods of the class, and you can do all of this at runtime. That's the best part. Then history. It was first introduced in Smalltalk language. Then Common Lisp object system came into picture. It was influenced by Smalltalk, but unlike Smalltalk, it also allowed multiple inheritance. In modern languages, quite a few modern languages have MOP. JavaScript has Juice, C++ has a library called OpenC++. Java has Reflection API, and Perl has Moose. I think you all are familiar with Moose? Yes. Okay. But why do we need a MOP? Are there any real-world examples where it can be useful? So the answer is yes. First example is testing. How many of you write test cases for your code? I guess all of you. So I also do, some but not all the time. So in the beginning of my talk, I mentioned that I work at booking.com. Our website is moving very fast. We have several rollouts a day, but we don't test everything. We do test critical parts of our system, but for non-critical stuff, we just rely on our monitoring. At one point, rollouts became a little bit hard. People were reluctant to rollouts because they need to test a lot of things manually. And it's a pain because it's easy to go wrong, and they take a lot of time, and it's boring. So this is this code depicts how our web handler looks like. For every part of our website, we have defined routes. So for search page, we have a route. For hotel page, we have a route. And for all other parts of our website, we have route defined in web handler. Now, if I want to run tests for all the routes of my website, then I can ask web handler to give me all the attributes, and then I can run tests for all of those attributes. Here's a pseudocode. Don't expect this to compile. So here I'm fetching all the attributes, and I'm iterating over them. Then I just check if there exists a parameter called URL. If there is, then just make a simple GET request to see if the page is loading fine, if there are any errors like 500, 400 or so. So yeah, so that's very easy to do. And what's the best part is that if, let's say, for example, I told you that our website is growing very fast. We add new features to our website, we add new routes to our website. So our web handler is also growing. And also we delete routes from our website, maybe on weekly basis. So if I'll hard code all of these routes somewhere, then it would be difficult to manage. It won't be scalable. So if I do it this way, then it's easy for me. I just need to add my route in web handler, and I don't need to change the test. So yeah. Next application is object relational mapping. How many of you use databases? Yes. And how many of you have used DBIX class? Okay. So DBIX class is an ORM. I guess you all are familiar with this create table statement. So I'm creating a table called hotel, which has a primary key called ID and two other columns, name and address. And here I'm using SQL parser to parse my create table statement, which will give me the table name. In this case, it would be hotel. Then I'm creating a class with my table name using Moose metaclass. Then I'll iterate over all of the columns of my table. I'll add them to my class using Moose meta attribute. Moose meta attribute creates an attribute at runtime. Then this is the name of the attribute, type constraint of the attribute, then reader and writer for the attribute. Then I set its superclass to some DB class thing, which some DB class thing has methods like retrieve and search where. So if I set some DB class thing as superclass of my class, then I will have these methods. So I can easily do this. I can ask for the hotel object, which has ID 123. Then I can ask for its name. Then I can set its name to something something. So that's it. Now let's see how to implement a MOP in Perl. So let's first discuss how to create a class at runtime. So in the beginning, few minutes ago, I told you that Perl class is a package. And every package in Perl has a symbol table. Now what is symbol table? It's a hash of subroutines and variables defined in a package. It has this notation like $, class name, and 2 colons. So here's my basic meta class. I will use it to create classes at runtime. Let's see what does it do. Here's the definition. I have a method called create class. I have, when I'll call create class, then I can pass a hash as the argument. And it can have a key called package, which will be the class name. Then it can have methods. Then I'll iterate over all the methods. I need to do this because if I won't do this, then Perl will complain. And here I'm manipulating the symbol table of Perl, of my class. I'm adding all the methods to my class. And I can do this. I can create a class called rectangle. I'm just passing the constructor method here. And it works. But there's not yet a way to get meta class of my class rectangle. So I've added this line in my code, in my create class method, which is pointing to get meta code reference, get meta subroutine, which is defined here. So it takes first argument as a class name. Then it calls get meta class. So let's see what does get meta class do. Here I'm fetching the value of my class from meta to class hash. And then I'm blessing it into meta class and returning it. But I'm reading it, but I'm not writing to meta to class hash anywhere. So let's do that. So this is a function which I'll use to set the meta class while creating a class. So this is set meta class. I'm writing to it. First argument would be the name of the class, and then I'm setting it to the meta class itself. And if I do this, then it works. I get this dump, which has a method named meta and a method named new. So now let's talk about inheritance. Every package in Perl has every package symbol table in Perl has an array called is_a, which has this notation, and it has all the parent classes of your class. So if I add these 4 lines in my create class, then I can define parents of my class at runtime. So here I'm just checking if superclass's key has been passed or not. If it has been passed, then if its length is greater than 0, then just put it in is_a. And I can do this. I can create another class called rectangle, a colored rectangle, which has superclasses, which has one of its superclasses as rectangle. Yeah, so it works fine. But please don't try these things, because it's incomplete and maybe fragile. I'll tell you why. So this is what man page of package stash says. It says that manipulating stashes, also called Perl symbol table, is occasionally necessary but incredibly messy and easy to get wrong. This module hides all of that behind a simple API. So I'm not sure if I've gotten all of it right. I might have made mistakes. So you should not do that. You should use the package stash or symbol table. Moose itself uses package stash to do all this metaclass thing. And also, metaclass PM is very basic. But actually, metaclasses are not so simple. If you look at Moose, it's not that simple. Moose has metaclasses for attributes, which will contain information about attributes, like type of attribute, its accessors, accessors, mutators, and things like that. And same for methods. Now, let's discuss inheritance and a problem which comes with the MOP. So here I have a class A, which has a method ifoo, and metaclass of A is meta A, which has a class of, which has, so A has a method ifoo, which calls C bar of its metaclass. And B inherits from A. B has ifoo, but metaclass of B, which is meta B, doesn't have C bar. So there will be a problem in this case. Let's see in code. So I added this method in my meta A. All of the code is just same as metaclass, so don't worry about it. And here I am I'm creating my class A. I've defined a method ifoo, and here I'm I'm fetching the meta class of my class. In this case, it would be A, and then I'm calling C bar on the meta class. And if I call ifoo, it works fine because meta A has a method called C bar. Now I have defined another class called B, which has metaclass meta B, and it has A as its superclass. But if I'll call ifoo of B, I'll get this, which is what I said before, that meta B doesn't have C bar, so it will not work. So here, let's look at it again. So if I'll call on B, then self meta will return me meta B, and if I'll call C bar on meta B, it will fail because there is no C bar in meta B. Now let's look at the second case. Now here I have my meta class meta A, which has a method cfoo, and cfoo needs to call I bar in A, and I have another meta class with meta B, which inherits from meta A, and B has meta B as its meta class. So B has to has a method called I bar, otherwise it won't work. So let's see in code. So this is my meta A. I have defined my method cfoo, which is calling I bar. Now here's my meta class meta B, which is inheriting meta A. And here I'm creating my class A, which has a method defined I bar. If I do meta cfoo and I pass A in it, then it works fine, because here A has a method called I bar. But if I do, then I create a class called B, which has a metaclass meta B, but it doesn't have a method called iBar. So if I call cfoo on meta B, then I get this error because there is no iBar method in class B. So which happens at this line. And yeah, so this is known as metaclass incompatibility, and there are various ways of dealing with this. So Moose just checks whether child metaclasses and parent metaclasses have any common ancestors. If they have, then it's all good. If they don't have, then it dies with this exception. So if you want to know more about metaclass incompatibility, then go through the code, just grep for this exception in Moose, and you'll understand more. Another way of dealing with metaclass incompatibility is to have mixins. So mixins is a combination of methods from other classes, and so it's included rather than inherited, and Moose roles are similar to mixins. In inheritance, order doesn't really matter, but in mixins it does. And mixins take precedence over non-mixins. So let's see an example. It would be quite difficult to understand this, so please bear with me. So I have my class, so A is a class, and M1 and M2 are mixins. B is inheriting from A and M1, M2. Let's see here. Yeah. So in that order. So if I apply rules of mixins, then I'll get this. So methods in M2 will take precedence over methods in A. So if I have a method foo defined in both M2 and A, then the method foo in M2 will take precedence over method foo in A. And similar thing will apply for M1 and M2. If there is a method bar in both M1 and M2, then the method bar in M1 will take precedence over method bar in M2. Now, I have another class, C, which is inheriting from class B, and it is including a mixin M3 in that order. So if I apply the rules, then methods in B will take precedence over method in M1. So again, that same rule, if B and M1 has a method with same name, then the method in B will take precedence. And methods in M3 will take precedence over B. Same rule. So yeah, so that's one way, that's another way of solving metaclass incompatibility problem. Now let's talk about MOP in Moose. It provides a great MOP. So I can create class using Moose metaclass. I can also pass attributes, and it is much cleaner than my metaclass. So I think you all know why I asked you not to try those things. So, and for introspection, the testing example which I showed you before, it makes use of introspection. That is, give me all the information about my class at runtime. So in Moose, you can use get attributes list if you want to get all the attributes of your class. For methods, you can use get methods list. For superclasses, you can use superclasses. And for changing definition of the class, you can use, if you want to add a new attribute, you can use add attribute. If you want to add a new method, then you can use add method. But there are some drawbacks of MOP. It makes things slow. And so if in your most classes, if you don't intend to change your class at runtime, then always do this package meta make immutable at the end of your class, because it makes things a little bit faster. And it tells moves that you're not going to change your class at runtime. And here are some resources if you want to know further about meta-object protocol. So first and last are quite important. First one is a book. It is illustrating MOP using Lisp, Common Lisp Object System, but it's I don't know Lisp, but I still managed to understand most of it. And last one, Stephen Little. He helped me a lot with this presentation in understanding some of the concepts. So yeah, so he's a great resource. And thank you for your time. I hope there will be a lot of questions about metaclass and compatibility stuff. Yes?
I have a question about what situation does that come up in? Why would you have, for example, a metaclass that inherits from another metaclass, and then the two classes don't inherit from each other? When does that come up?
So in real world, I tried hard, but I could not find any examples.
Oh, okay.
So I can't really say in which cases you'll see it, but it is something that you have to take care of. Like, you never know. Yeah.
So since most of the time one doesn't mutate classes at runtime,
Yeah.
how come they're not immutable by default when you tell Moose if you want to mutate them instead of the other way around? Do you have any insight into that?
Okay, so you're asking that why it's not immutable by default.
Yeah.
So that would be, I mean, so mutating a class is a runtime thing. And if you're making it immutable by default, then how's it going to work? I mean, it's like,
Well, you would have to tell it at compile time, I suppose.
yeah.
The same way you tell it at compile time that you don't intend to mutate it.
Yes, we can do that, but I don't know why they did not do that. So yeah, but you can file an issue on GitHub Moose. So
I'll get right on that. Thanks.
okay. More now?
There's a bunch of different implementations of this on CPAN, like one that I've been using, MOO.
Yes.
Is like a subset. Is that using the same underlying code? Right?
So as per my understanding, Moo doesn't really provide you a MOP. I mean, I'm not sure, but as far as I know, you can't create a class at runtime using Moo. It does provide you all object-oriented syntax. Like, you can define a class, like as you do in Moose, the normal way, not using create class. But you can't do things at runtime. Like, you can't create a class at runtime using Moo.
The interface is similar. So
Interface is similar, yes. But, I mean, because for adding meta classes, I mean, there's a lot of other stuff.
yeah, there's limitations.
Yes, so Moo just provides object-oriented thing for which Moo has. So if you don't need if you don't plan to use meta object protocol of Moose, then don't use Moose and use Moo instead. If you just need all the object-oriented thing.
Okay.
So yeah. More? Okay. Thank you.